All right, let's dive into one of the biggest challenges and honestly one of the biggest opportunities in AI development today. We're going to talk about how you go from just messing around with the chatbot to actually building real, reliable applications. We're talking about LLM engineering.
You know that feeling, right? If you've ever tried to get an LLM to give you some nice, clean data for a program you're writing, you know exactly what I'm talking about. You ask for a simple JSON object, and what you get back is, well, it's a little too chatty.
I mean, look at this. On the left, that's what you want. Clean, simple, machine-readable. But on the right, that's what you often get. Of course, here is the data you requested, and all that stuff. Now that's fine for a chatbot, but for your code, it's a disaster. A single extra word, a little bit of friendly chatter, and your entire program just breaks.
And this isn't just some random quirk. It's a really fundamental issue that we call the chatbot mindset problem. But, and this is the important part, it's not something you have to just live with. There is a solid engineering solution to fix this for good.
So let's unpack this a little bit. Why does this even happen? Why are these incredibly powerful AI models so darn chatty when what we really need is precision?
Well, it really all comes down to their training. LLMs learn from a mind-boggling amount of human text, from books, articles, conversations. They're designed to be helpful and conversational, not to be a strict code compiler. You know, in our world as developers, a missing comma is a total catastrophe. But in a conversation, nobody cares. So just putting return valid JSON in your prompt is basically just crossing your fingers and hoping. It's a brittle approach, and it's just not going to fly in a real production system.
Okay, so that's the problem. Enough about that. Let's get to the fun part, the solution. This is where we stop hoping and we start engineering. Welcome to the world of structured AI outputs. And this visual right here, this captures the entire goal in one shot. LLM engineering is all about taking that messy, unpredictable conversational stuff on the left and reliably, every single time, transforming it into the clean, structured data on the right that our apps can actually use. It's about building a machine, not just having a chat.
And this right here really nails the mindset shift we all need to make. We have to stop thinking of the LLM as this chat buddy that we have to gently coax into doing what we want. We need to start treating it like any other software component, like a function you can call, an API endpoint that is forced to return data in a very specific way.
So how do we actually do that? How do we enforce those rules? Well, it comes down to this really powerful one-two punch of two key technologies, a library called Pydantic and a feature called function calling.
Okay, first up, Pydantic. The best way to think about Pydantic is as the blueprint for your data. It's a Python library that lets you define a super strict data contract, but with code that's actually easy to read. You're basically handing the AI a precise architectural plan for the exact data structure you want it to build. Let's make this real with a quick example. Here, we're defining a recipe. The class itself sets up the container. Then we're saying dish name has to be a string, just text, and prep time minutes must be a whole number, an integer. And that last line, that field with a description, that's kind of like a secret weapon. It gives the LLM a rich, human language hint to help it find the right information. It's code that's also a high-quality prompt. Pretty cool, right?
So, if Pydantic is our blueprint, then function calling is the contract that enforces it. This is a feature in modern APIs like from OpenAI and Google that literally forces the LLM's output into a specific shape. Instead of just writing whatever it wants, the model is told its only job is to generate the arguments for a function we've defined. And guess what? That function structure perfectly matches our Pydantic blueprint.
So when you put it all together, the workflow is just beautiful. It's this simple three-step dance. Step 1, you define your blueprint with Pydantic. Step 2, you hand that blueprint to the LLM as a contract using function calling. And step 3, you get back a perfect validated data object every single time. No more conversational fluff.
Now, this is way more than just cleaning up data. This technique unlocks a whole new universe of powerful, reliable AI applications that, honestly, were just too brittle to build before. Let's check out a few. First up, accurate citations. Think about RAG systems, where you give an AI documents to read before it answers. You have to know where it got its information. Well, by defining a schema that requires both a fact and a direct substring quote from the text, we force the LLM to show its work. We make it provide verifiable proof for every claim, creating AI systems that are actually auditable and trustworthy. Or what about complex reasoning? Look at a question like this. It needs multiple steps. You have to find data for one country, then another, then do math.
Instead of trying to do it all at once, the LLM can use structured outputs to generate a step-by-step plan, just like this. It figures out the workflow before it does anything. It's literally learning to think before it acts.
Now this one is a total game changer for anyone who works with data. You can just throw a messy report at the LLM, one that has tables and text all mixed together. By defining a schema for what a table looks like, the model can go in, find all the different tables, and pull them out into a clean format that's ready for data analysis.
And finally, this is the magic that powers all the powerful AI agents and assistants that are popping up everywhere. When you ask something like, "What's the stock price for Google?" the assistant uses this exact technique to reliably pull out the function it needs to call, like get stock price, and the parameter, in this case, Goog, so it can call a real-world API and get you live data.
So let's just pull all this together. What's the fundamental shift here? What does this discipline of LLM engineering really change for us as builders?
The main takeaway is this: we are fundamentally transforming the LLM. It's no longer this unpredictable, kind of fuzzy, probabilistic chat partner. It becomes a reliable, predictable, deterministic software component that you can actually build a business on top of.
This quote from the source material just sums it up perfectly. Our job as developers completely changes. We stop writing fragile prompts and complicated parsing code. Instead, we just focus on defining what data we need with a clean Pydantic schema. And we let the LLM handle the hard part, the how. It figures out how to read the messy text and structure the data for us.
And this just blows the doors open for the future. I mean, this isn't just about extracting data anymore. This is about giving AI the ability to reliably use any software tool we give it. So it leaves us with this huge, exciting question. When an AI can build and use its own tools with this kind of precision, what on earth are we going to build next?